today we're going to talk about 4.5. 4.5, we are talking about solving quadratics. So when we are solving quadratics, if that quadratic crosses the x-axis in two places, these two places are actually your solutions. Sometimes we call these solutions the zeros of the function because your y value is 0, right? Now, if I was to take that same parabola and maybe move it up so it only touches the x-axis, how many solutions does this one have? This has one solution. One solution. And I do want to briefly touch on, what if your parabola is way up here and doesn't cross? Which means there are no real solutions. So today we are actually going to we're going to do 3 ways to solve quadratics today, and we're going to do 3 ways to solve tomorrow. Okay? There's 6 ways. This is all a review from Algebra 1. Okay? So the first one we're going to talk about is what we call the zero product property. Zero product property. For the zero product property, you set any factor with a variable equal to 0 and solve. This gives you your solutions. So, for example, if after I factored it, my factors were 3x plus 2 times x minus 5, I would set each one of those factors equal to 0. So 3x plus 2 equals 0, and x minus 5 equals 0. And the first one I would subtract 2 first. 3x equals negative 2, and divide by 3. So my first solution would be x equals negative 2/3. This one I'm going to add 5 to both sides. And so I get x equals 5. These are the 2 places where the parabola crosses the x-axis. Right? Yes. Not like that, though. Not like what you're thinking. I got your back. Okay, Chase, we got this. All right. So I want to do some examples using the zero product property to begin with. Okay, because the first 8 problems are all using the zero product property.
Is there a way that you can use the zero product property for all of them?
No, because not everything factors, unfortunately. That's why there's so many different methods. All right, so here we go with example number 1. Example 1, using the zero product property. Solve. Let's go with x squared. X squared minus 5x equals 6. So before we can actually factor this thing, we have to get it all in standard form on one side, right? So I got to move that 6 over. Okay, so I'm getting the whole thing set equal to 0 first. So I'm going to subtract 6 over. So I have x squared minus 5x minus 6 equals 0. So now I'm going to go ahead and factor it. Draw my x. Negative 6 on top, negative 5 on the bottom. Good try. If that was a positive 6, I'd completely agree with you. Negative 6 and 1, I agree. Negative 6 and 1. So now my leading coefficient is the one I can draw or write my factors, x minus 6 and x plus 1. Now, at this point, I have my factors. Any factor with an x in it, I said equal to 0. So I have x minus 6 equals 0, and I have x plus 1 equals 0. In this first one, I'm going to add 6 over, x equals 6. In this one, I'm going to subtract 1 over, and I get x equals negative 1. So what that means is this parabola crossed over here at negative 1 and over here at positive 6. So it did something like that. Give you kind of an idea. All right, let's try another factoring one. I don't think so. I'll try another factoring one. Example number 2. I'm going to ask that you solve. Let's go with 4x squared plus 12 equals 0. Oh no, 12x, sorry, 12x equals 0. All right, so the whole thing's already said equal to 0. Step 1. Take out the 4x. Beautiful. Good job, Chase. Take out the 4x. Leaves me with x plus 3. Now, remember the zero product property says any factor with a variable in it, you set equal to 0. So this greatest common factor has an x in it. So I'm going to set that one equal to 0, and x plus 3 equal to 0. Here I would divide both sides by 4, and x equals 0. Here I'm going to subtract 3 from both sides, and x equals negative 3. Those two solutions represent what? Where it crosses the x-axis. That's correct. All right, let's get one more. One more. Example number 3. And then we'll go to the next method. And I'm going to ask that you solve. And let's go with 3x squared equals x plus 4. All right, so the very first thing we want to do is get the whole thing set equal to 0. I want to remind you that we want our leading coefficient to be positive. So instead of moving this to that side where I have a negative on front, I want to move everything this way. That's correct. You could. That's the same thing, right? So I have 3x squared minus x minus 4 equals 0. Now I go ahead and draw my x. Last number times the first is negative 12. Middle number is negative 1. Last number times the first. Yep. All right, now I need two factors of negative 12 to give us negative 1. Perfect. Negative 4 and 3. So then I go to my box. First term is 3x squared. Last term is negative 4. My diagonal is negative 4x and 3x. Out of the top line, we can take out an x. Out of the bottom line, the only thing I can take out is a 1. Up and down, what can I take out? 3x, good. And here, what can I take out? Perfect. So I have 3x minus 4, and I have x plus 1. And now I set those factors equal to 0 and solve. So this first one, I'm going to add 4 over. So I get 3x equals 4. Divide both sides by 3, and x equals 4/3. Here, I'm going to subtract 1 from both sides, and x equals negative 1. Okay? So that's all I'm asking you to do for the first 8. Set it equal to 0, factor it, set the factors equal to 0, and solve them. Any question? All right, I want to talk about the square root method, because sometimes that's an easier method to do. The square root method. The only time you can use the square root method, it's the easiest one, but you can only use it if there's no b term. So for example, let's say I had 4x squared minus 16 equals 0. I have no b term. So here what we can do is we can just solve for x. First, by adding 16 to the other side. So I add 16. So I have 4x squared equals 16. Then we can divide both sides by 4. So I get x squared equals 4. And then how do I get rid of the squared? Square root it. Square root both sides. And we get x equals plus and minus. So anytime you square root a variable, plus and minus 2. Now technically that's the difference of squares, isn't it? So we could have factored it as well. Since that's the difference of squares, we could have factored it, and you get the exact same answer. It's up to you guys. Just showing you another method. All right. Last method I want to talk about then is graphing. Excuse me. So the last thing we're going to do is graphing. When we graph, we are looking for where it crosses the x-axis. Okay? And we are going to be using our graphing calculator to do so. All right? So when we use our graphing calculator, you are first going to go in y equals and put your equation, which I'm going to give you an equation in a second. And then you graph. After you graph, we go second, trace, and down to 0. And then enter, enter. When you hit enter, down in the bottom left corner, it's going to say left bound. You have to move your cursor. So let's say I have this, and my parabola looks like this. You have to move the little flashing cursor till it's above or left of where the 0 is. If here's my 0, left of it is right there on my parabola. Then you hit enter. As soon as you hit enter this time, then it says right bound. So now you're going to move your cursor below where it crosses. So for right bound, and then you hit enter. When you hit enter on the second one, it comes up with these little dashed lines that surround your 0. You hit enter one more time, and it's going to tell you your answer. Now, if it's over here, the left side is actually below it, and the right side is above it. So it depends how your parabola is on where the left and right bound are. So that's what we need to talk about. So here's our first one we're going to do together. Example 4, right? I'm going to show you, okay? Just a second. I just want to get all the steps there. So here we go. Graph. To solve. And let's go with y equals 2x squared plus 3x minus 5. All right, so I want you to put this into y equals. Then hit graph. Trace is on the top. Then hit graph. You're going to get something that kind of looks like this. Do you have to head back, Colin? Can you hang out for a minute? I might need your help. Okay, thank you. I had Mr. Southgate last hour for my help, so if you're willing to help. All right, so now we want to go second, trace, and down to zeros. And hit enter. Okay. you're going to get a flashing cursor. You need to move our flashing cursor above this first solution. Okay, so we go second, trace, down to your 0, hit enter. You want to move your cursor to the left for that left bound. And you see left bound at the bottom. Good. Hit enter. Then you're going to move this cursor by pushing to the right. It goes below it. Enter. Gives you the little dashed lines, and then you hit enter one more time. So our first one, x equals negative 2.5. Your y should be 0 no matter what.
So it doesn't matter when you place those little things?
No, as long as it's to the left and the right. Now we got to do the other side, though. Okay, so we're going to do it again. We got to go through those steps again. This time, though, when you move it to the other side, your left bound is actually below where it crosses, and the right bound is above. See if you can find that one for me. Here's the error. Huh? 1 is correct. We are looking for those solutions. And you have, on your homework today, you have 6 of them that follow the same idea. I'll actually 7 in a second. Okay? Did you get it? Yep. Okay. All right. Anybody else? Anna. Maria. Okay. So left bound, you want to go, if you're doing this side, you want to do to the left of that point. So anywhere in between where you are and where it crosses the x. So move it up a little bit. Yep, going to the right. Okay, now hit enter. Okay, now we're going to go, see how it says right bound? Now we're going to move it above the x-axis. Hit enter. See how it says guess? That just means it's thinking, and you hit enter one more time. See, it tells you right there. Okay? All right, how's everybody else doing? Good? Good? Okay. Just like that. X equals and x equals. Huh? No, actually you won't need the graph once we get onto the homework. All right. Okay, so okay, so we're going to start. You got a graph in there. We're going to start back at the beginning. Second and trace. Go ahead. No, second and the word trace right here. Okay, go down to 0. Hit enter. Okay, now you want to go to the left side of where this is. You want to move to the left until it goes above the x-axis. Until it goes above the x-axis. Yeah, keep going a little bit more. A little bit more. Okay, now you can hit enter. Okay, now it says right bound right here. So you want to move it down until it's below the x-axis. Okay, hit enter. And then it says guess right here, so you just hit enter one more time. There's your first solution. Okay, and we have to do the whole thing again to do this side. Uh-huh. Okay. All right, hey guys. Hey. Extra conversation. This free round is not necessary. Thank you. Well, Colin, can you help Danny real quick? Thank you. Well, y is 0. You guys listen. I've had this conversation, or this question a couple times. When you're finding this point, I told you this already, the reason it's called a 0 is because your y value is 0. We just want to know what the x is because we know y is going to be 0. It's where it crosses. So we just need... Okay. We'll see if we can get that figured out. And then I'm going to go, let's see, I got one more problem to go over, and then, yes, but I want to make sure we understand this graphing thing. So the next one, we're going to kind of work with that. Yeah, example 5. 15. Okay, hold on one second, don't disappear yet. Oh, yeah. All right, here's example 6. Thank you. 5. Here's example 5. One more second. Thank you. If you don't mind. I mean, if you want to go back to class, you can. Okay. So, Colin tosses a ball out the second story window. The function h of x equals negative 16, or sorry, h of t, my bad. H of t equals negative 16t squared plus 24t plus 5 represents the path of the ball. All right, so right now, imagine here's Colin up here in the second story window. He tosses a ball, kind of gives it a little loft, and it comes down to the ground. All right? So my question is, how long before the ball hits the ground? So if I want to know where it hits the ground, what am I actually looking for? I'm looking for seconds. What else am I looking for? Okay. You try my question again. I want to know when it hits the ground, which means I'm looking for the 0 of the function, right? Right? Because the height of the ball when it hits the ground is 0? Yes, okay. So we're going to put 0 in for h of t. Now, the easiest way to do this is we're going to graph it. Now, technically, when you graph it, this parabola also comes this way. Why do I not want that 0?
Because he's not throwing it backwards, he's throwing it forward.
Can't go back in time, right? Can't have negative time. We want to know the time. So I want everybody to graph this function. Yes.
Is the left bound, is it going to be switched if it opens?
Yes, it is.
The left bound is
If right here your left bound is going to be up above,
and right
bound would be below. Yes. Okay, so I want everybody to try this. We're looking for how long before it hits the ground.
Can it just be
Yeah. Yes. Same thing. Okay, you're going to put it all in your calculator. So into your calculator, yes, you're going to type this as negative 16x squared plus 24x plus 5. Hit graph, just like we did on the previous problem. Well, they're the same thing because it's the distance. You're talking about the amount of time it takes to get to 0. Yeah. So it's really covering this amount of time till it gets to here. Right.
I keep trying to answer to put my right side in, and it keeps saying
Okay. So, will you walk around and see how everybody's doing? I'll start here. Okay. 0.
enter.
Okay, you want to go left bound is above. Oh, not that far. You want to do this one.
I was starting last.
I know, but we don't want that one because it's negative.
Oh.
Yeah, we don't need that one at all. Okay? Yep, so that one. Go above first.
I thought left was below.
Left is above when it's upside down like that. And one more time.
Where at when I put it?
Well, it says guess. No, you just, on guess, you just enter it one more time.
Oh.
That's it. So how long did it take?
1.68.
5, 6, 8, 1.685. Yes. Okay, so the left bound, let's cover this all together. The left bound is above because this opens down, and the right bound is below. Okay? And Chase, tell me again, what did you get? 1 point what?
1.685.
Good. 1.685.
It says split. No, that's because you can't. You're trying to do them together. You have to do them separate.
All right.
He's doing what I did. I tried doing them.
Oh, yeah.
left
Okay.
is on the bottom.
Okay. Right. So what I was talking about is over here, that's negative. We don't want negative because you can't get a negative time. So all I want is this point that's on this side. So all I want is this point. That's the one we got to find.
Okay.
So let's go second and trace. Okay, go down to your 0. Enter. All right, now we got to move our cursor till it's above over there. Yep. Okay. Yep, beautiful. Hit enter. Now go below. Hit enter. See how the lines are around it? And it says guess. Just hit enter one more time. There you go.
Thank you.
Okay. Did you guys get it? Okay. Oh. Your graph, let me see. Your graph is off. 16x squared plus 24x. Oh, it's plus 5.
Oh.
That's why. That's okay.
I was about to say.
That's an easy fix.
Yeah, I was like,
All right. Okay, yep. Down to your 0. Good. We want to do this one over here. So you got to push all the way to the left so you're above that side. Oh, sorry, all the way. Sorry, my bad. I'm upside down. Yep. Yep. Enter. Then go below. Oh, on the same side. Yep, hit enter. See how those lines are surrounding it? Now hit enter one more time. There you go. Okay. All right. Did everybody get it? Okay. Thank you, Colin, for your assistance. I greatly appreciate it. All right. So you have one word problem on today's worksheet. Let me get this to you. I highly recommend that you start with the last 7 problems because those are all you're graphing it to find the zeros. All right? Now, one thing further on this word problem. If I said to you, what is the reasonable domain for this problem, what would you tell me?
No.
Now, is that reasonable? I mean, we're talking about a ball.
No, it's not.
Right. 0 to,
Positive.
no?
Negative. 0 to 2.
Okay, so we're talking, okay, cool. We're talking about the domain. We're talking about what, in this case, is the t value or on the x-axis. 0 to where did the ball hit the ground?
0.
Yes, so our reasonable domain would be from 0 to 1.685. That's the reasonable domain. Huh?
Do we have to put the domain?
For that question on here, yes, it's asking for the reasonable domain. All right? Anybody else? Okay. Let me get you guys the worksheet. See if we can't